Just to introduce everybody, our technology manager from CTI, Jeff Miller, is with us today. I'm Randy Briggs, manager of the CTI Research and Development Center. And also with us is Rich Falco from his home in Florida. And of course, our presenter today, Jim Kokonis. Jim is going to take us through the objectives of this class, and then we will go ahead and kick it out. The rest of us will be monitoring chat and Q&A for you.
I'll be monitoring chat too. Trying to.
Okay, it's all yours, Jim.
Awesome. All right, let's get some things set up here. Share screen. One more thing I want to see from here's a quick little question to start the conversation off. When you guys are working on HVAC, I want to set an expectation. I want this to be as interactive as we can make it for you in this type of a format. This is one of the things we've been working to develop for some time now, and the current situation has just helped us push it further down toward the finish line. But we're looking for a way to have a class that's a little bit more interactive without people being able to be in a classroom all the time necessarily, some other ways of presenting material. So I have the ability to do some different things. One of the things is, even though I have a presentation up, I could bring a video in, and you guys should be able to see and hear this. So my question becomes, you guys know a quick way to test the functionality of your HVAC sniffer or leak detector? What do you see on the screen? Solvent. An amazingly beautiful lift somebody sees. Actually, this is a bottle of washer solvent, and I had a whole bunch of different, excuse the beeping, I had a whole bunch of different types of detectors here, both infrared and heated pentode and different things that were all current or very recent certifications, and they will respond to washer solvent. So I won't run that whole video, but is everybody able to see that and hear the audio? Just answer back, yep, in chat. Awesome, great. So listen, you guys can make comments in chat. How many of you guys can figure out how to raise your hand in this thing? Go ahead and do that.
Oh yeah, there we go.
5, 7, yeah, you guys are quick. Awesome. Go ahead and put them down. Perfect. So if you've got a question and you're trying to get somebody's attention, please reach out and do it that way. You can actually pull down Q&A. Q&A actually will enable you to ask a question directly to the panelists, or you can ask it to the whole room so everybody can see what the question is. Some of those questions may be answered in the background. Others of them we can actually bring out into the conversation. We do have the ability to unmute someone's mic and bring them into the conversation. So keep that in mind. I'm actually going to pull my participants list out over here. Those for functionality. Here's another test. You guys able to see the scan tool? And this is not a video. Randy will have to blur that VIN out. Live car. And pulling up data. Let's make sure I've got good connection. Car looks active. And I have a very special guest assistant. So let me get them on. Can you start the vehicle, please?
Get started.
Okay, we're pulling data then. Thank you. And air conditioning on max.
Okay.
Cool, thank you. All right, so we're going to have that up here live in a short period of time. So let me give you the gist of this particular class. When we start talking about dealing with HVAC, and we look at what some of the practices can tend to be, and how the problem solving on these vehicles is approached, a lot of times the default seems to be, let's make sure it's fully charged. A refrigerant machine will come out, we'll pull everything out, put it back in to make sure the car's fully charged, and that seems to be a starting line that we see a lot. As the cars have gotten newer, we've got a lot more data, we've got a lot more ways to analyze the vehicles and the systems and how they're operating. And so the question becomes, why aren't we, or are we using that to its best effect? There have been some aha moments and lessons that I've experienced, and this particular Toyota is one of them. I was doing a bunch of research on Toyota when this vehicle, actually I was doing a bunch of research on HVAC systems for automatic climate control when this vehicle was brought into the research center for us to take a look at. It had been in for service with a shop that works on a fair amount of hybrids, and they had replaced the evaporator in it because it was leaking. And so the vehicle was repaired. It was early in the springtime in North Carolina. Temperatures are pretty moderate, humidity's pretty low, and the vehicle went out for about a week, and it came back with a complaint. And what the complaint was that the AC had two modes of operation: blistering cold, or fry you out hot if the engine was warmed up, obviously. And it would be one or the other. So if you put it on max cold, you were going to get ice cubes out of the vents, and if you went up just one click on the control, it would switch over to full heat. And so the first thing we wanted to do when we brought this vehicle in was, okay, let's verify the customer's complaint. Does everybody agree that's a pretty standard place to start, verify the customer's concern? Yes, no, throw it up in chat, guys, talk.
Yep.
Just need to know everybody's tracking. So if we pull up some data stream and we look at a couple of PIDs, like what the position of the blend door is, and if the vehicle is running the compressor, I mean, we can see the compressor's running at over 4,000 RPM. The evaporator temperature sensor is starting to drop down. It's about a 75-degree day. But we can see the door's in the cold position, and it's starting to cool down. The compressor's running. And if you see the set temperature there, PID, that set temperature driver's side, it's not a dual zone system. There's only one on this particular car. Went up one click on the temperature request, and you can see the set temperature has now gone to 64.4 degrees. And guys, this is in Fahrenheit. I don't have all the conversions for Celsius in here at this point in time, if you're used to the metric system. But you can see that instantly the compressor RPM starts to drop, the evaporator temp sensor starts to climb, and the air mix damper has gone fully in the opposite direction. So the customer is describing what's going on with this thing 100% accurately. It's either one or the other. So it's an on or off switch. Now, the tech that was working on this, when you look at Toyota service information, they say there's two ways to approach an air conditioning problem. And one way to approach it would be symptom-based or performance-based diagnosis. And, I know how air conditioning works. Let's take a look at what it's doing. And the other way is to follow DTCs. Well, obviously, if you don't have DTCs, you're going to follow symptoms and tests. But if you have symptoms and tests, you may follow those anyway without looking at DTCs, because we don't tend to take a scan tool. Some of us don't tend to take a scan tool into an air conditioning problem. So when we look at service history on this thing, and the fortunate thing is the shop that worked on this particular car, they had a lot of parts and donor cars and things like that. So it wasn't like they, went to the parts department and loaded up the cart and came home. But it's like, okay, so the blend door is acting bizarre. Let's try a blend door. Let's try a control head. Let's try an amplifier. And some of these suggestions came off of some of the help sites and things like that, people suggested, have you run the calibration utility on it since you had the thing apart? And when we think about that, if on a lot of the newer cars, if we have them apart, one of the things they'll say precautions in service information, it doesn't have to be a Toyota, it can be many different cars, is when you put this thing back together, you should have had the battery disconnected. When you put it back together, you should run the door control utility or the door calibrations. And that could be a standard procedure on some cars. It wasn't on this one. So the car's in, and what's the first thing you do if you're going to get a scan tool out? What's the first thing you do on a modern car? Do you just go straight to the issue that you're looking at, or do you take the scan all modules? I see a whole car scan.
Whole car scan.
There it is. The guys are jumping on this quick. Thank you for using the chat like that, because this is how I teach in class. I like to talk with you instead of at you. So you're helping me out with chat because you're keeping me engaged, and I know you guys are there. So here we go. Here's an example of an all module scan. Now, there was some interesting conversation on this. I'm sitting here looking at this, and there's open squib codes that are history. Nothing's current there. There's some PIDs for loss of communication. With what we know about the history of this car so far, is anybody really concerned with those? Kyle, you guys see that comment in chat? Kyle's like, I'm trying to preach that to my guys currently.
Preach on, Kyle.
Preach on, preach on. Is anybody really excited about these airbag DTCs or anything at this point in time? Matt says no. Common codes possibly. So here's my thinking.
I'm always excited.
I'm always excited. Awesome.
You
Brian.
know who that is.
Yeah, oh yeah. Welcome, Brian. How you doing? The way I'm looking at this is the vehicle has just had the dash out of it. There have been some difficulties with it. There's probably been a lot of things going on. It hasn't been returned to the customer yet. So we could have set some codes in the testing and repair of this vehicle that just haven't been cleared out yet. Since their history, I'm going to kind of move along and look for things that I'm interested in. So now we get down here to the air conditioner. That one about lost communication with the AC control module or the AC amplifier, well, they probably plugged one up and changed it with another one, and might have done it hot, and who knows what happened. But when we get down here to the air conditioner, we see 3 codes, and 2 of them are the same: the room temperature sensor circuit and the solar sensor. And both of them are current, and one of them is current history, the room temperature sensor circuit. So it's like, okay, there's some information. Here's my question to you. That solar sensor circuit, who would get excited about that on a Toyota right now? Because that's a heat load input for the car. Should we be excited about that code right now? Somebody says it's normal when the vehicle. Okay, so most people know this. That's great. And that's a good one to know. This car was in the shop when it was scanned for codes, and if it had a left solar sensor and a right solar sensor, I'd have 2 codes for each one. If it was outside in the sun, now it's something to pay attention to. And the beauty about it is Toyota clearly says that in their service information. Not every manufacturer will set this code, so don't look for it on everything. What is the room temperature sensor on a Toyota? Is that in your office, giving you your temperature back home? What is it? Evaporator temp. No, it's not evaporator temp. It's not evaporator temp. So the room temp is, yes, it's the temperature in the car. Dylan just dropped in on that comment. The room temperature, some manufacturers will call it cabin temperature. Toyota and Ford do something similar with that, though. not only is it sampling the temperature of the air in the cabin for it to make adjustments to how the air conditioner is operating, trying to hit target temperature, but it also samples the humidity level in the room so that the system can make decisions about passenger comfort and how to run it, as well as the likelihood of fogging or mist on the windshield, both inside and outside due to humidity and how we're running the system. So that's just something to pay attention to. So that's the one we're going to look at. And Toyota said, well, we can go off of our knowledge or we can go off of the DTC. And so I'm going to kind of show you a path where we split the difference on this. We could chase the DTC very directly, or we can just take a look at this and we can say, okay, what does service information tell me about this code and about how this sensor works? And so the room temperature sensor on this Toyota, if it goes open circuit, it doesn't default to what's the most common default temperature sensor data you've seen? Like if a coolant in -40, somebody jumped on that, -40, -40. And I've mentioned this in every presentation because that is so common to see that if we have a failed or a dead battery on a tire pressure sensor and it used to provide temperature data, guess what you can tend to see in data stream? Your tire is -40 degrees. But on air conditioning systems, pay attention because those numbers won't always default there. A Ford ambient air temperature sensor, the last one I looked at, defaulted to 50 degrees Fahrenheit. And if you caught it just as you open the circuit, you may see it momentarily dip to that like -40 on the graphing. You had to be graphing to catch it on the scan tool. And then it would drop in and drop that 50-degree default. Toyota defaults this one to 20. And if it's a shorted circuit, it's going to go to 135. Now, I had an attendee says, you know, he likes to look at the min and max on a scan tool to get an idea of whether a circuit might be shorted or open based on how they scaled the min and max. And I thought it was an interesting idea. I'm mentioning it to you here, but I've tended to not trust ranges on even factory tools all the time. So I'll put it out there. I like to get what is expected out of service information. So if it's normal, it would give us actual temperature. So if we drop in and look at the data, what jumps out at you right here? What are we told to look for? There, 20.3, 20.3 degrees, 20.3 degrees. And notice that the humidity sensor, what does it show? I told you it was early spring, 75 degrees. We're not in Florida. And it's showing 90% humidity. And that room temperature sensor on this car is two sensors in one. Does this look like an open circuit on that sensor? Absolutely. Now the question becomes, what's the likely cause? This thing has just had dash work done to it. It worked for a week and then stopped. What do you guys think is going on? Was it never plugged in if it worked for a week? Or maybe did it not get locked in? Loose connector. There it is. That's what I was looking for. So that's the operating theory right now. So after looking at the data and we say, all right, let's make a logical choice for the next thing to look for, we got to look for the wiring harness. And that's the little sub harness that runs up from the lower part of the dash up to the humidity sensor. The thing didn't have the belly pan on it yet, so I was able to look right at it, gave a little tug, and there it is. That's the connector for the back of that sensor. If you take a look at how to get in there, it's a little difficult. The piece where that sensor bolts, if it's in place, even with belly pans on, you really can't see it. But I was able to kind of get in there from one side with the fingertips of one hand and feed the plug up with the fingertips of the other. You know, that mechanic skill where we have eyeballs on the end of our fingertips and get it plugged back in. And what do you see in data now? Give me the three things you see that prove that this thing is fixed. I'm looking for 3 pieces of information. 3579 on the humidity, the 68-degree setting in the door position. Brandon, it's almost like you've seen some of this. But that's exactly, we have 3 keys to prove that we're fixed. So does that make sense, folks? Using the data to help guide our diagnostics. It's using logic. It's having a plan. It's saying, okay, what could be the root cause of this? What would my expected behavior in data be if the system was low? What if I had a failed door? Have you guys ever, I mean, how many guys remember the time of year when you would replace a battery on a General Motors, typically a pickup truck? And if you knew anything about those door motors, if you lost battery power, those door motors would lose their position memory for the ends of their travel. And so when you connected the battery, the next time the air conditioner was turned on, those door motors would drive all the way to one side, feel the stall, drive all the way to the other side, feel the stall, and then they knew where their endpoints were for the rest of their motion. And if you think about that, when the cars had some age on them and the plastic gears in those door motors, we didn't do anything to the air conditioning system. The car came in with a dead battery, we put a battery in, and when it fired back up, it broke a door motor. And then they would be like, ever since you worked on my car, it only blows full hot or full cold or whatever it is. If you looked at those door motors in data stream because of how they were built, if you tried to move them, you would see the door data in the scan tool jumping as the gears snapped over. So it would try to move, but it would just bounce back and forth. So those are ways we've been using data for years to get an idea on direction. So let's see. Let me see if I can get another example here before my assistant has to take off and take our test vehicle away. This is a 2012 Camry. This vehicle is 8 years old already. Looky here. Refrigerant gas volume check, as well as servo motor initialization. So there's a way to recalibrate those doors, and if you look in service information, it'll tell you to do that anytime a battery's been disconnected. And then there's a refrigerant gas volume check. This vehicle can run a test and tell you whether or not it thinks the refrigerant level is low. Now I've got to be in the vehicle for that, and I'm not right now. So I'm going to back out of there. Let's go to see what they've got available in active tests. So we can actually control the blower motor, we can control the compressor clutch, and we can control some of the air dampers, and we can give it commands and we can watch the position. So we can do that. We can also look at live data. Now, how much data do you think we have on an 8-year-old car? What refrigerant's in this car? This isn't 1234, is it, right, guys? When we talk about evaluating air conditioning systems from the driver's seat, there's a couple of PIDs that I like to look for. Some manufacturers make this easier than others. Some manufacturers make this almost impossible. I'm not picking on anybody. I'm just telling you a reality. When I connect to a late model GM like a Camaro, and I'm trying to get multiple pieces of data all on the same screen, because of the way they break out the data groups and what modules you get them from, you may not be able to put all the pieces onto one screen to evaluate. Some people will say, well, I want to go right and test a component, but I'm going to look for things like regulator control current, the flow sensor, the evaporator target temperature, the evaporator actual temperature. I'm going to take those up to the top. And you can see right now, if you'll notice that ambient air temperature, it's only 67 degrees here. because we had a cold front blow through. It was almost 80 before, but I can't control the weather here. I can do a lot with the scan tool and broadcasting it online, but I can't control the weather. So I apologize. So this air conditioner is not working really hard, but let's take a look at the data and see if we can understand and prove that. So I'm going to take off what should I take off? I'm going to take off that regulator control current, and then I'm going to graph merge. And there you can see everything's running pretty tight together. But right there, blue, see how the fin temperature started to go up right there? And you see red, the flow sensor actually started to drop down. Well, the flow sensor on this compressor, when the voltage goes down, it's reading an increase in flow out of the air conditioning compressor. And so if you see what happened there, they were all running tight together. The evaporator temperature had gotten up higher than what the system had set as a target. And so it actually increased the flow out of the compressor to cool the evaporator down more. And then it backed out of that flow when it had hit its target temperature. Does that make sense? And I told you it's only 66 degrees outside. Because I understand how this particular system works, if I look in Toyota service information, that regulator control current, Toyota says the typical control range is between 0.5 amp and 2 amps. So normal data should be somewhere between 0.5 amp and 2 amps. What did we say the temperature was? 66 degrees. Is this system working really hard to get that 40-degree temperature in there? Nope. Exactly. It's not working hard at all. And if you think about this, even if it was 75 degrees, if I saw a drive on that compressor toward the low end, and I am hitting my target evaporator temperature for the current setting in the dash, that system is not only performing, but what do I know about it? Is it doing all it can do, or does it have more to offer? That's the question I want to answer. And so tell me, looking at this, is it doing all it can do, or does it have more to offer?
Much more to offer.
Much more to offer. That's exactly what I'm looking for. It's got tons of headroom. Here you go, Scott. That's the kind of answers I'm looking for. So this thing is kind of lumbering along right now. And what I'm going to do is I'm going to go ahead and tell my lovely assistant that I am done with the car. And I'm going to disconnect from it. And I'm going to let her get to an appointment, which is important. And I've got some other data in this class about this car. And if we get to it, I'll show you an example of some captures that I pulled when it was like 85 degrees. And you'll see that it still has plenty of headroom, even at 85 degrees. So somebody says if the system was low on Freon or refrigerant, would the current be higher? Yes, it would tend to be higher. If the load on the system was more, if it was a hotter day, the current to the control valve would be higher. So let's get into a couple of other things. How do we use data? And how you use data is going to change the more you get into these systems and you see what you have available. This is a 2011 Jeep Grand Cherokee, and it's got, this particular one has 7 blower settings, and it varies the output to the motor. Can you diagnose switch issues in data stream? Well, sometimes you can. Sometimes you absolutely can. And if you saw missing steps, you might know that there's a bad spot in the control head. Now, some of them may seem like they look a little interesting. This particular scan tool, sorry, one of the anomalies we noticed is the system didn't have an auto setting because it wasn't auto. There was no rear step. The settings, the clicks for the front blower were just, manual 1, 2, 3, 4, 5, 6, 7, and you could feel those clicks on the button as you rotated it. And so the scan tool had perceived data stops for things that weren't there, and that's why it looks like it jumps right over. There's nothing wrong with this particular vehicle. Let's see. If you look at this particular capture here, it says if you're on the blower setting that's listed here, 1, 3, 5, 6, whatever, the voltage to the right should be what's available across the blower motor. Now, this thing is pulse controlling the blower motor through a duty cycle, and it's telling you that on setting 4, you should have about 6.5 volts. On 7, which is max, you should have over 12 volts. It doesn't tell you something specific because we understand that's going to be based on system voltage. So if the front blower is off, in data stream, we can see that there is 0 pulse width. So that's the off position. If we go to the next value, or we turn it on, and we're at manual 4, what do you see there for the pulse value? You see that, do you see that, what do you see for duty cycle there? 51? Does that correspond? I mean, we're all talking, we all love to talk scopes and engine, diagnostics and all that stuff. Position 4, about 6.5 volts. What's system voltage? Typical system voltage, 13 volts, 14 volts, somewhere in that range. So if I am running a pulse width of 51%, is that going to give me about half a system voltage, or about 6.5 volts? So we can look at these types of things, and maybe I don't have a scope, maybe I can't look at the pulse width. But if I've got a command and I understand how it works, and I go across the blower motor and I see what that available voltage is, I can use these things for quick checks on diagnostics to make sure it's running right. Okay? Other things. How many of you use system performance checks as defined by the manufacturer to test for the performance of an HVAC system? Throw your hands up if you use them. And I mean, you set the controls where you want, you set the doors and the windows where it's supposed to be, and you put the AC on a specific setting, and you measure pressures and temperatures. How many people have ever done that?
Got a handful.
Got a handful. Well, if you've never done it, you're going to find out really quickly with a lot of these new systems, the old rules of thumb are out the window. Rich, what was the running high side pressure on that Ranger? And it was normal, and it was like 70 or 80 degrees out. Wasn't it like 90 pounds?
93 pounds on the high side.
93 pounds on the high side. And it was perfectly normal, and it was cool out of the vent.
That was a truck with less than 1,000 miles on it.
A truck with less than 1,000 miles on it. And so if you are going to run a performance test on a vehicle, and you're going to try and do it off of that card somebody wrote for you in the 50s and you stuck in your hip pocket, it's going to lead to some issues. And so learning how to find that data from a manufacturer is going to be beneficial. Here's an example of a vehicle that if you look up the performance test, and Rich, correct me if I'm wrong, it was everything closed, air conditioner on max, and the driver's window open 6 inches?
Yes.
Okay, so the driver's window opened 6 inches. So a closed up cabin, and you would run a performance test on it. And here I'm going to kind of reiterate some of the important pieces of data. This vehicle has been running for about 5 minutes at least. It's stabilized. And if you look at that, the evaporator temperature has gotten down to 37 degrees. If you look at the command for the solenoid valve on the compressor, this one's running at 70%. And I don't recall it being super hot, Rich. It was somewhere in the 80s.
Low 80s, high 70s. Yeah.
Okay. And go ahead.
I was going to say, I remember from the performance chart, the maximum vent temp is 48 degrees. So our vent should be 48, and right now our evaporator is sitting at 37. So this system's working just fine.
Nice. Okay, the high side, that looks pretty normal for what we would expect on most cars. And then the person who was running the test, you know, they got a little bit uncomfortable sitting in the seat with a scan tool. So they, so, you know, you pop the door open a little bit so you can put your knee out to the side and set the scan tool on it. You don't open the doors wide open, and then you just watch the vehicle react to it. And look at how quickly it starts to change. The compressor's been commanded to 80% duty cycle. The temperature's gone up about 9 degrees. The high side pressure's staying pretty close to the same. We're just pushing a little more flow through this thing. A little while later, it's jumped to 98% control. There's our 48 degree, quote unquote, max vent temperature, but we're losing control of this system. And now it's up to 100% duty cycle and 48 degrees at the evaporator fins. So we're going to get a little bit warmer than that coming out of the center of the dash. It's trying hard. That's exactly right. Oh, Scott's noticing that the evaporator temp looks like a translation issue. And this is an exact example of why I said I don't typically trust ranges on scan tools for min and max values for the PID, because I've seen some of this before. Scott, I don't recall, I don't think we had this hooked to a GDI or a different tool, but I would be willing to bet that that's probably a pretty wild and wide range for this thing. But it was a newer vehicle for this platform at the time. So it was definitely data that could have potentially been tweaked in the coming future. Okay. There's some other things on here that I do want to get to. If we take a look here, we've got ambient temperature filtered. We do have an air quality sensor PID on this one. We have passenger compartment air temperature PIDs. We've got a lot of data in this vehicle. But what do you see on this page that caught our eye? John picked up sun elevation. Azimuth and elevation. For those of you who have not seen some of the trends on systems, there are newer BMWs that are out that don't have a recirculation button. That functionality has been taken away from the driver. There are manufacturers making vehicles where, and I'm going to say it this way, I'm not trying to be controversial or anything, but the HVAC system is so marginal that the default for performance is going to be recirculation mode. And so they have a strategy built into them to maintain air quality in the cabin, that every so many minutes an hour, they open up and exchange the cabin air for fresh air by opening up the recirculation on its own without an input or control, just to maintain air quality in the cabin. And then when we take that to the next level, you've got systems that are using Yeah, somebody typed CO2. That's exactly right. We have human air pollution inside because we're breathing out CO2. And then you have systems that are watching GPS data, direction of travel, and time of day to augment the sun load on the passenger compartment, as well as potentially to determine, hey, we're getting ready to go into the Hampton Roads tunnel, and I'm going to turn off fresh air and go to recirculate because I know my air quality outside the vehicle is about to degrade. So that's the type and level of data that we're starting to see now. So let's see. Oh, there's another piece that would catch your eye if you start looking at some newer GMs. If you worked on older GMs that used to develop cabin odors or mustiness in the inside of the vehicle from humidity, we used to put on what was called an afterblow kit. It was a timer and a relay and wires to the blower motor that would make the blower stay on after you shut the key off. Well, now, modern car, it's all software, and you can turn it on and off with a scan tool. All right, looking at time. Let me show you a couple of slides from performance of a vehicle driving. This is that same Camry I had hooked up live earlier. And this screen capture, I remember it very clearly. It was a warm day, and the vehicle had been driving. And if you're unfamiliar with the scan tool, that target temperature of 33.8 is here. And the evaporator temperature in blue, the data you're seeing here is at this position in the screen. So what's coming in? Remember the flow sensor, the more flow, the lower the voltage goes. The less flow, the voltage starts to come back up. So driving along and in traffic, it's going from Maryland down into Virginia, and came up to a red light and the vehicle stopped. And so now we don't have the airflow across the front of the condenser. And you can see right here, the fin temperature in the evaporator started to climb. So it went from being pretty much right on target temperature, where it went up about a degree and a half. And instantly that compressor responded by starting to output more refrigerant to load the evaporator up and try and bring that cooling back down. It hit a point where it decided it couldn't get it any lower than what it was and started to back out of it. But that's typical behavior of response of the system, and that's normal operation. And if you take a look at it, to understand how dynamic the system is going down the road, here is that target temperature again, just above freezing. Vehicle is set to max cold, and you can see the evaporator fin temperature actually got to a point where it got colder than the target. And as soon as it got colder than the target, about in this range of the graph, because we're driving down the road, so engine speed and everything is coming into play with how responsive the output of that compressor is, trying to maintain that comfort level. 8-year-old car, nothing new, but you can see when it got down to where we were approaching freezing temperatures, it backed out of that flow to try and warm that evaporator back up to prevent it from icing. You guys find this data useful to understand it's there and to get an idea how well the system's working or not working? Cool. Here is an example of a graph on startup of the system. So basically just push the button and turn the system on, and it was set to go pretty cold. You can see that evaporator fin temperature was climbing because the system had been shut off. And as soon as we turned it on, the regulator current in red kicked off and dropped into that just above a 0.5 amp range. and the flow sensor went really low because there was a ton of flow. But what would happen as the pressure starts to build? Can you see that as the pressure builds, that's going to fight against the flow? So this arch right here is caused by the pressure starting to come up. And then everything settles into an equilibrium, and this system gets a hold of it and gets stabilized. And that's pretty much how that system is going to work straight up. And of course, I've showed you a lot of data out of this car. The scan tool doesn't show the calculations in the background. I'm going to show you another car here where it does do that. It gives you conditions for when to run the test and then gives you a result. And all the Toyota will do on this one is say, there's nothing going on. The system's not low. The gas volume is normal. Somebody says almost like air fuel ratios sensor response. And, you know, that's, as I sit here and I look at this stuff, I'll show you a picture out of a Chrysler that's looking at duct temperature and controlling the blend door for that channel. And you can watch them chasing each other, just like short-term fuel trim and an O2 sensor. It's pretty impressive. Okay. Speaking of which, one of the reasons I say to pay attention to data is I was in a late model Tundra and I pulled up this data, and anytime I see something in a scan tool, and I don't care what system I'm in, if I see a piece of data and I don't understand what it is or I wonder what it's for, excuse me, I'm going to go look it up. Taking a look at this data, what piece of data do you think caught my eye? Answer in chat. Give you a minute to look it over. It's worth it. Cool air bypass. Cool air by. Do you guys actually, have you seen it? Do you know what it is? Just say yes or no. No. See that? Okay, that's cool. You guys saw it too. So we all think the same. It's like, what in the world is that? Well, allow me to explain. The front of a Tundra is a pretty big cabin space. And so Toyota actually changed the airflow and the distribution. Normally when we think of this, we'll take air from the blower motor and it'll go across the evaporator. We'll have that on for defrost or to help set an appropriate temperature. And then we'll blend it for the left and the right across the heater if we need to add some heat back to it. And then we'll distribute that to appropriate places within the cabin. And that's normal operation. But if you look at what happens, they deliver warm air lower in the cabin and they can bypass cooler air around the heater core through that cooler air bypass door to put toward the upper section of the blend chamber. So what's that going to give me? If I'm putting the heat out toward the floor and the cool air up top, I'm going to get a natural convection and mixing, and it's a way of them getting a better blend in cabin temperature and allowing it to mix in its final presentation to the passengers. So yes, and you get cooler air on your face, which I don't know about you, but if you wear contacts, the heater can dry contacts out really fast. System performance tests. Somebody asked in one of the classes earlier this week was, did other vehicles have, cool down checks or performance checks for the AC? Here's an example of a 17 Cherokee that I'm not going to get into how it's laid out, but the performance test actually has the ability to do both a cool down and a warm up test through the scan tool, and the results are displayed, and you may even be able to bring up the results of a previous test. So this system will test itself in case it wants to set a code for a performance issue. And so if you're using the scan tool to do this, I've only done this on this car with the YTech at this point. I haven't done it with another scan tool and captured it for you yet. But it actually gives you the criteria of what the scan tool is looking for, what the system is looking for it to pass or fail this test. So it needs to see a 15 degree Fahrenheit or 8 degrees Celsius drop at the evap temperature sensor and a 15-pound increase on high side pressure in less than a minute. So they're looking for a 15 degree cool down on that evaporator in less than a minute. And the evaporator has to be above 70 degrees to start. So this one kicked me out because it said it wasn't warm enough. So we blew a little hot air across it and then got it to run. And we actually got a results table that looks just like this. What the pressure was at start, what it was at finish, and you can see that all those criteria that it set, it hit within the time frame. Helpful test? How many people knew that was there on the new Chryslers? If you didn't, check and see if your scan tool will do it. And the other thing I'll tell you is Chrysler, they do some different things with how they handle their data and give it to us anyway. But when you went into the data on the HVAC system on that 17, there were 125 PIDs in the HVAC module. So there was plenty of data to evaluate. This is the slide I was talking about where you can see the panel duct left temperature sensor and the main or left temperature door position. And so you can see the door position almost chasing those little changes in temperature, trying to even out the temperature that was being delivered. Scott, I pulled that data almost 3 years ago. I would have to get that car and get another. Rich says he's seen it in Alltel and launch. There you go. Thanks, Rich. All right, looking at the time, we're getting close here. I tell you what, I'm going to put this slide up, and I'm going to give you a couple of things to think about when we talk about using data to diagnose an HVAC system. The kind of things I'm looking for and trying to learn how to use and evaluate, trying to understand known goods on every car I can get my hands on. I'm looking for pressure PIDs. I'm looking for temperature data. I'm looking for control PIDs. And what I mean by that is those, what's the percentage of command, what's the duty cycle, what's the amperage, depending on how that car displays it, and figuring out what normal data is. I'm looking for logic, like compressor allowed or disallowed, because there could be conditional inputs that are false that disallow the compressor from operating, and I'm spending time chasing things around when I've got an open ambient air temperature sensor, like some of the Ford Fusions were shutting down air conditioning compressors over that. I'm looking for tests that are in the scan tool. So can I run that automated filling test? Can I force a compressor to kick on so that I can try and make a decision? Is this a networking or communication issue, or is this something directly with the compressor? The other thing that I'm looking for are settings and customizations. And the reason I say this is the engineers are making these systems more responsive to customer likes and demands. And there are certain behaviors that are defaulted on from the factory that can be turned off. And what I'm saying, for examples of that, is like when you turn on defrost, a lot of systems will default the air conditioning compressor on if conditions warrant drying the air before I blow it across the inside of the windshield. And if you have a car that allows you to break that default, so where somebody can turn the vehicle to defrost and the air conditioner will not be commanded on unless you do it manually, could you find yourself chasing a customer's complaint because they bought this car secondhand and a customization has been put in place in that car that if you don't know about it, you're chasing a failure that's an internal software dip switch, if you will, that somebody said, hey, I just don't want it to do that because I don't want it to do that because they read about it online and it's cool. And yes, I went and looked and people were in there doing this kind of stuff just because. And there's a couple of ways to see that stuff. You'll either see a flag for that setting in data stream, or you have to know how to get into the menus and change it. And then on the other side of the coin, you take that example of that Chevrolet that had the ability to turn on that afterblow function. If you have a customer that comes in and, their complaint is, wow, I'm getting some musty smell in my car. One of the first things we look for is, have you ever changed your cabin air filter? Because we know how much those things can hold on to aromas. And then the next piece is, does this vehicle have this afterglow feature and did anybody turn it on? The other thing you can look for is when you shut systems off, a lot of them will have the ability to open up that fresh air vent to allow the moisture and humidity that's in the case to off gas and to dry out faster. So I'm looking, Randy, it's 2:02. That's an hour. And I'm happy to stick around for some Q&A or some feedback if people are willing to give it. So I am going to stop my share.
Okay.
And put us back in gallery mode and off we go.
There we go. Well, I've seen some just awesome comments and questions come through chat today. I would like to ask the attendees as a group for a little input via chat, and that is what you're feeling about traditional diagnostic paths for HVAC. That is, grab a set of gauges, grab your RRR machine, maybe temperature and pressure. And how much has this expanded your diagnostic possibilities in the HVAC area? And you can answer that through chat if you would. Okay. We're seeing some interesting comments come up here too. Well, Rich, anything to add today?
Stay tuned for next week. Thanks for coming. More to come.
Next week's going to be a big one, and this will be ongoing, so please join us.
A couple of people asked about, will this be posted anywhere? We are recording.
We are recording, and in the very near future, we're going to be hosting this on CTI online through our LMS, and so you should have availability there.
How many people have ever heard of using an enthalpy chart to diagnose an air conditioning system? I'm debating showing a completely different technique. What do you think, Rich?
Brandon said, enter stage left, Tim Izzy.
Nice.
Always happy to learn more.
Awesome. Well, we might.
And a couple of what?
What?
So, Jim, what is it?
What is an enthalpy chart? When you look at refrigeration, there is a temperature and pressure chart that creates a kind of a lopsided dome, and everything to the right of that is fully a gas, and everything to the left of that dome is fully a liquid, and anything in the middle is changing state. And it's the old way they used to teach air conditioning, and it is the data that HVAC professionals, the guys that do home and commercial, they've been using this stuff for 50 years. And somehow in automotive, we got away from it. And it's gathering 4 pieces of data and plotting it on a chart to get an idea of how efficient an HVAC system is operating. And I played with this. Randy, how many years ago was it?
Oh,
was it
gosh,
this is 4 or 5 years ago?
About 4 years ago, we started wading into this pool. And looked overwhelming at the time, but like any new skill, as soon as you got your head around it and practiced it a few times, you saw some real value in it. So,
And then if you don't like to do the math, there's actually a way to do it where you hook up a set of gauges and some temperature probes, and the piece of software does it for you. But to me, it's just a visual verification, and we might do that as a future example for just here. And
Yeah.
keep in mind, this was what, Randy, a handful of slides out of 2 classes that are combined 8 hours of time, and I only used a handful and went an hour here. So that's an example, is if you come to the automatic climate control classes or take those full classes live online, you'll see everything that fed into this sample presentation.
So if all you guys out there, if you liked our content, if you like the way that we teach, all of our instructors across the country and Canada have very unique and personable teaching styles. When the world gets back to normal again, search out classes in your area on CTI Online if you're not a participant already. Okay, well, guys, let's wrap it up for today. If there's nothing left to add, I want to thank everybody who participated today. If you like what you saw and you want to keep track of it and see what's coming up,
Da, 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 da. There it
Oh,
is.
there we go.
ta-da! You can look at virtual classroom events on CTI Online. Search the training tab at the upper part of the page. Scroll down to virtual classroom. There'll be a link to that in your follow-up email. Our sister company, WorldPack, with their World Automotive, Professional Automotive Community videos, will be on CTI Online also. So